Hello, you are welcome to today's class. In this class, we'll be considering a partial differentiation of vectors. Partial differentiation of what? Of vector. Why do we have partial differentiation at first? Why do you think we consider partial differentiation? Is any part of differentiation that is partial? Is any part of when we have partial, therefore we must have what? Total. Okay, so if we have partial, there will be total. So can you differentiate the example of a partial vector or total what's it called, partial derivative or total derivative? Sorry, can you help me together clean? So can you differentiate between partial derivative and total derivative? Let me know in the comments, or you can make research. You can try to browse what is the difference between partial, and I'm going to show you how you can identify a total derivative and a partial derivative in this class. Okay, now we'll be solving these questions. Imagine you have to answer this in an exam, and you're told that you're given something like from question 1 to 7, just like this, something that you just answer within few minutes and get your total mark of 7. So this video is for you. All right, now the first one say we are given a vector f to be this. You're given a vector f to be 2bi. This I here, it signifies durations. Take note, I, j, and k here, they signify what? Duration. You remember in physics, you were once taught something like this, that for the I is in x direction, j in y direction, and k here in z direction. Okay, so that's I, j, k there, it represents what? Duration. Take note of that. Okay, all right, now we're given that vector f is equals to 2bi plus open bracket a square minus 2b close the bracket j. That is, this is for I in the direction of x-axis, this is for j in the direction of what? Y-axis, and this is for k in the direction of what? Z-axis. Okay, now how to differentiate a partial derivative and a total derivative is that when you see a derivative like this, for example, if you see if they write derivative like the f over the you have the x over, let me just say for example, now you see a derivative like this one. Now to get the total derivative, we know we have a function. The function matters. Let me show you something here. The function is do what? It matters. If you see, we have many functions there. We have a function and we have b functions. That is the two functions we have. Okay, so you need to calculate for both of them for you to get the total derivative. But in a case whereby you have one function like this, for example, if you have y equals to maybe 2x plus 2x squared plus 2x, now you will see that this is just a function. Y is a function of just only x. X is here, x is here. It's just a function of x. So total derivative will be something like dy over the x. The d will be written as a perfect d, like this. Perfect, the way you usually write your d. But if it is partial derivative, they will not write it as this form. Instead of them to write it like this, which is the normal d, they will write it like this. Can you signify the difference? This is the difference. This symbol represents a partial derivative. Why the normal way of writing d is represent a total derivative. You understand? A total derivative. So if you are asked to calculate a total derivative here, now how are you going to do it? You will calculate partially, that is, you calculate for a first. You know, if you are calculating for a, it is partial because b is there, and you then calculate for b again. You then combine the two of them together, will give you what? Total derivative. So that is how to find a total derivative of this. You can watch out my video on partial differentiation of vector and at the same time implicit differentiation of vector. I have video on that already on my channel. Okay, now let's quickly go on to the problem given before us. Now let me erase this. Now let's write solution. Let's write solution. Okay, let's write the vectors out first. We're given vector f. Do we need to write it? For the sake of space, I don't need to write it. We can be looking at it here. So the first one says, number one, says partial derivative of f to a. It is partial because we are considering f to a alone. F to a alone. As I've said, we also have b, but since we are considering a alone here, so it is partial. In case in a place where you have two variables and you are dealing with one, you don't deal with the other one. Is it not a partial? It's a partial. It's a partial. And take note of the symbol of partial too. Take note of that as I've explained. Okay. Now we are dealing with f to a, which means anywhere there's no a will be automatically 0. Now here now we have a here, we will differentiate it. We have a here, we will differentiate it. But here there's no a here. It will be what? 0, because we are dealing with f to a. So here will be 0, okay, and here we will differentiate because there's a. But here we also tend to change to what? 0, because there's no a at all. So how are we going to do it? The partial derivative of f over the partial derivative of a equals to, if I'm to differentiate, I'm differentiating f with respect to a. But the reason why this place will not, we know we have b2, but the reason why it will not change to 0 is that there's a. So what I will do is that I will keep this and every other one constant except a. I will differentiate a, but I will keep these two constant. So if I keep these two constant, I will not differentiate it. So if I keep them constant, I will have 2b, right? I will have 2b, but before I put I will need to differentiate a here. I will need to differentiate a here. So to differentiate a now, if I differentiate a now, it will be a raised to the power of what? A raised to the power of 1. Of course, you know that if I differentiate this, if I use 1 to multiply it, if I use the 1 here to multiply what is here, it will still give me 2b, right? So if I then subtract 1 from the power, whenever you are differentiating, you always subtract 1 from the power. Take note of that. It is when you are integrating that you add 1 to the power. So if I subtract 1 from it, it will become a raised to the power 0. And a raised to the power 0 will be 1. So 1 times this 2b to still give me what? 2b. So let's put our I there. I, okay? Plus, I'm differentiating a raised to the power of 2. A raised to the power of 2, a raised to the power of 2. I will use this 2 to multiply it. I will use this 2 to multiply it to be 2 times a raised to the power of. Instead of me to write 2, I will subtract 1 from it. I will not write it as 2. I will subtract 1 because anytime you differentiate, you subtract 1 from the power. Okay? So if I subtract 1, it will be 2 a, 2 minus 1 will be 1. And 2 a raised to the power of 1. A raised to the power of 1 is the same thing as what? A. That is, this will give us what? 2a. Take note of that. That will be 2a. So it will be 2a. But if I differentiate this, I need to, if I differentiate it, it will automatically give us 0 because there's no a. So let's just put our j at the back. J plus, if I differentiate a, what would it give us? That would be 1. Because this is it. I've explained it. This a has a power of what? 1. A visible power of 1. So if I'm to differentiate it, it will be 1 times a raised to the power of, I will subtract 1 from the power before minus 1. So this will be 1 times a raised to the power of 1 minus 1 will be what? A raised to the power 0. And a raised to the power 0 will be 1. 1 times 1 will still give me what? 1. Okay? So this will be what? 1. So it will be 1k. You know that 1k is the same thing as k. So let's just put k. All right. So now, this is our answer for what? For the partial derivative of f to a. The partial derivative of f to a. Now, I've done for f to a, but you now do for f to b. Partial derivative of f and what and b. Drop your answer in the comments. It's very simple. The same thing you here you keep. Let me just show you the how you are going to do it. But I'm not going to do it for you. But if you are wrong, I will correct it. I will correct you probably in the comments. Okay. So you just keep this 2a constant because you are differentiating b. When you differentiate b, what will you have? Use to multiply it, then put your I. Here will be 0 because there's no b. Take note. Here now you differentiate b. Whatever you have, maybe if it is 2, you put 2j, and here here will change to 0 because there's no b. Differentiate this and put it there. You see that it's very, very simple. Okay, try that. Differentiate this and drop the answer in the comment. So I will do the rest, everything. I'm going to solve it in this video. But this is the only one I will give you as exercise to solve. As what? Exercise to solve. All right, let's quickly go to number 3. Let's quickly go to number 3. Or let me just solve it. I will give you another exercise to solve at the end of this class. Okay, so I'll give you another exercise 2. So we are given the partial derivative of f with respect to the partial derivative of what? B. So equals to, now we have b here. So I will keep these 2 a constant. The reason why it will not change to 0 as I've explained, because there's b here. So I'll keep these 2 a constant. I'm differentiating this b. So let me put the 2 a constant first. Now, before I put I will differentiate b. If I differentiate b, you know, when I differentiate a, it will give me 1. Likewise, if I differentiate ordinary b, it will give me what? It will also give me 1. Well, 1 times 2a will still give me 2a. Just put the what? I at the back. Okay? Plus, this will change to 0 because there's no b here. If I differentiate this one now take note. This minus belongs to this. This minus belongs to this. And mind you, there's a plus. This plus is this. So here now we have minus 2b. Minus 2b. Now, if I differentiate minus 2b, now if I'm differentiating b now, it's the same thing as power of 1. So if I use the 1 to multiply minus 2, it will still give me minus 2. B raised to the power of what? 1 minus 1. Okay? So minus 2, b raised to the power of what? 0. B raised to the power of 0 will give me what? 1. 1 times minus 2 will still give me what? Minus 2. So everything here will change to what? Minus 2. No longer what? It's no longer plus. So it will change to minus 2 or sorry, I'm coming. So this will be minus 2 what? 2j. It will be minus 2 what? It will be minus 2j. Now, here now, there's no b here. So that will change to what? 0 on its own. There's ink inside, but it's like the marker is already feeding it. Okay, so let's just continue to manage like that. So here now we don't have b here to change to 0, but there's b here. There's b here. So I will differentiate b square. So b square, you can see there's marker inside. So 2 times what is there to be 2 times b raised to the power of what? If I differentiate, I will subtract 1 from it. Okay, that will be 2b. Okay, so that will be plus 2bk. So that's our final answer to this, which is the number 2. Number 1 is this. Number 2 is this. All right. So now we want to look at this number 3. Now you see that this number 3 now is now second derivative because of these 2. It's a second derivative. But it is a second derivative of what? It is a second derivative of f with respect to what? A, not b. We now look, you know, what we're going to do is that this is the first derivative, f to a. Whatever we have, which is this, is first derivative. So if you now differentiate this again, it is then we have square here, 2 here. So which become second derivative of what? Of this. And that is how we arrive at these 2 now. Okay? So this one is a second derivative of what? This. So now, where is this? It is given to be number 1 here, which is this. So if we now differentiate it again with respect to a for the second time, you know the a is square now, with respect to a for the second time, it will then give us the value of this. So let's make a try. Let's give it a try. Okay, let's give it a try. All right. So we have 3 is equals to the partial derivative of f is to the square f over the partial derivative of a square, which is this. I'm not differentiating this with respect to a. Anywhere there's no a, automatically change to what? 0. So here it's automatically change to what? 0. So I only have here this one too, automatically change to 0. So the only part I will differentiate is this. So I have 2a. What does that give you? Of course, here is raised to power 1. 1 times this 2 will give you 2. 1 minus 1 will be 0. So a raised to power 0 will be 1, right? So 1 times this 2 will still give me 2. 2 what? It is 2j. So the partial derivative of f with respect to a for the second one is what? Is given to be 2j. That is our final answer to that. So let's look at number 4. Number 4. So number 4 now. Number 4 says the third derivative of f, the third derivative of f with respect to what? With respect to a for the third time. For a, with respect to a for the first time, with respect to a for the second time, and with respect to a for the third time. So we have gotten the second time. So we now differentiate this second time one more time to give us what? To give us the third derivative. So to get the third derivative, we are differentiating with respect to a. A, check, is there any a? The remaining one we are left to say, does it have a? It doesn't have a. So automatically this one will be what? 0. Very simple something. That's what I'm telling you, that it's good. Like day before yesterday, there was a live class. Today there's another live class. Next week Sunday too, there will be another live class. And take note of that. We are even possibly Friday, and our live class now may be Friday. It may be Friday, Saturday, and then Friday, Saturday, and Sunday. But Sunday is very, very static. Sunday, very, very static. Just make sure that you follow us more on this channel. Subscribe, so anytime we go live, the YouTube will automatically notify you. Okay, and you can see that I'm picking from your textbook. This is where the lecturer, any lecturer from any universities or teachers, they can just pick questions from here. And so even though if you are writing this in white or jump, you can come across questions like this. So that's why you have to make sure that you watch the video. You can watch it over and over. Share it with your friends. Let them learn too. Okay. All right. Let's proceed. Now we are done with number 4. You are done with number 4. So let's look at number 5. Now we are differentiating f with respect to b for the third time, which is for in terms of b. Now this one is in terms of b, but we have not even differentiated the second time, not to talk of the first time. A we differentiate for the second time, which is this, but b we have not even done for the second time, not to talk of what? not to talk of the third time. So we need to differentiate for the second time and then differentiate for the what? For the third time. So I believe you have written this. So make sure to write it before I erase this. Let me erase this. Did I erase this first one? Let me just leave this one and this one. So I want to manage the remaining space here so you can keep writing. Okay? So let's come here. Now we are dealing with this. So we need to differentiate this for the second time to have the second derivative of f with respect to b, and then differentiate for the third time. So let's manage this space. So the second derivative will be this f over this. Now come here. We are differentiating with respect to b. Take note, not a. So anywhere there's no b, will automatically change to 0. This will change to what? 0. This, because there's no b here, this is 2j. It will change to what? 0. Let me write it very well. This is 2j. It will change to 0. We only have b here, so we differentiate with respect to this alone. Only this. So if I differentiate 2b, I kept saying this many times. B raised to the power 1 times this 2 will give me 2. Then subtract 1 from that one, it will be 1 minus 1, which will be 0. So b raised to the power 0, maybe 1. 1 times this same 2 to still give you 2. Always put your duration at the back, which is k. So this will be 2k. Now if I'm to differentiate it for the third time, which is number 5 himself, therefore number 5, the third derivative of f with respect to b is equals to, we have gotten the second one, so we are going to differentiate it. We are going to differentiate it again to have the third derivative. But now, do you have b? Do you have b here? No. So this will change to 0. So automatically this one will be what? 0. Okay. Now the next one to look at is this. You'll be surprised. Which one is this again? You'll be surprised. It's very simple. Don't worry. This is very, very simple. Okay. Okay. Should we solve it here? Let me just try to solve it here. Okay. Someone said as wait. All right, let me check if there's any question online before we proceed. So, sorry, I was told that there was a person that asked me to wait. So let me check if there's any question online. Just a minute, please. So that I want to carry everybody along, actually. That's my aim, to make sure that you carry everybody along. No one is lagging behind in any aspect. Okay. Just a minute. Okay, let me check. Please wait. Okay. Nice. Okay. Please wait. Okay. Someone say nice. All right. If you have any question, feel free to drop it in the comments. Feel free to drop your question in the comments. Drop it in the comments. I will keep checking. Okay. I'll keep checking. Make sure to drop your question in the comments. All right. Let's solve the next one, which is 5. Oh, we are done with 5 already. So we want to solve this one. Now, what this thing is trying to say is that let me break this one down for you to understand this very well. For you to understand this very well, and likewise this. So permit me to erase this part. I believe you have written this part now. Although you can keep watching the video over and over, you can come back and watch it. It's with okay. Someone say something. Can you change orientation of the camera? I'm sorry, sir. Please, since some are just joining, just help us summarize 3 and 4. Okay, 3 and 4. Okay, someone asked me to someone said the first one. Okay, can you redo the first one? Okay, is that number 1? Number 1. Okay, so for the sake of people that are asking questions, just stay connected. I want to explain briefly everything again from where I started to this point. Okay, so let me explain. Now, we are talking about a partial derivative. We say that for us to have a partial derivative, there must also be total derivative. And there is a way you can identify a partial derivative in question and a total derivative in a question. There are 2 ways majorly. Now, if you look at this very well, we have f with respect to functions like a and b. We have 2 different functions here. Take note, you see this I, j, and k. They are not functions. They signify durations. You know, in physics, you might have been taught that we have y-axis, x-axis, and z-axis. So your y-axis, your I is in the direction of x-axis, your j is in the direction of y-axis, and your k is in the direction of what? Z-axis. That is for that. Now, that is what this I, j, and k represent there. Because it is a vector. You know, we're told that vector has both magnitude and durations. So that is to identify the duration. But now, this is a function of a and b. So when you have a function of a and b, and you are differentiating with respect to a, is it not a partial? Is it only only a that is here? No, it is not only a. So when you differentiate with respect to a, it is automatically, without anybody telling you, you seeing this, you have already know that it is a partial because we have function of a and b. So, and another way you can identify a partial differentiation is that this is how they write total differentiation. For example, if it is total differentiation, they will write it like this. For example, if I write dy over dx, do you see the way this d now is being written? This is how to write total derivative, the way you write your normal d. But if it is partial, they will not write it like this. They will write it like this. Partial. You can see the difference. Partial derivative of, for example, now partial derivative of y over this. We make use of this partial whenever we have 2 or more functions. Take note of that. We make use of partial whenever we have 2 or more functions. But if it's just only one function, for example, if I have y equals to 2x squared plus 3x. Now, y is a function of x alone. There's no other variable here. We don't have v here. We don't have w here. We don't have k here. And sorry, we don't have g here. We don't have c here. We don't have anything here. The only variable we have is x. So if I'm to find the y dx now, it is automatically total derivative, not partial derivative. Take note, because we only have one function. But in case you have two functions, like let's assume you have w here now, or you have w here, since there's w here. Now, if I'm finding the y over the x now, it is a what? It is a partial, because we also have w here. So that is automatically to show that that is a partial. But if it is total derivative, if it's just only one function you have, it is automatically total derivative. And as I've said, another way you can identify is their symbol. Look at the way they write. Look like something like bend, like this. Bend. Partial derivative. You can see the way they write partial. Why, if it is total, it will be written like this. Can you see the difference? All right. So that is for that. Permit me to erase, or let me leave it so that in case you want to write it down. Now, that's, if you look at these questions now, it's talking about the partial derivative of f with respect to a alone. So you'll be considering where there is, this is f with respect to a. Sir, are we doing physics 101 today? No, we are not doing physics 101 today. We are not doing physics today. Maybe well, let's look at this week. I'm going to take physics this week, and possibly chemistry and mathematics. I'm going to take physics, chemistry, and mathematics. So just make sure that you connect, and I can continue this question. I can go to parabola, hyperbola, or equation of a circle, all those ones. So what I noticed that they usually set in exam, that's what we are going to cover. So we are going to have live class as at any time as possible. So just make sure to connect. That is just it. We can even have it in the evening. You can have it in the evening. I can go live at any time in the evening, but just make sure to connect so that they will notify you. Take note of that. Okay. Now we are now f with respect to a. We are concerned with a. Anywhere there's no a, it will automatically change to 0. So now we have a here. We will differentiate this. We have a here. We will differentiate this. But here there's no a. It will automatically change to 0. We have a here. We will differentiate this. There's no a here. It will automatically change to what? 0. Now this will change to 0. This will change to 0. But now I'm to differentiate this with respect to a. So I will keep this 2 and b constant. I will leave this a because I will differentiate this a, but I will keep this and this constant because they are beside it. They are beside it. What I have concern is this. So I will differentiate this. Why is it that this does not change to 0? It does not change to 0 because there is a there. The b here will not change to 0 because there is what? Because there is a. This one is because there is no a at all. There's no a at all. That is why this one automatically change to 0. Here too, there's no a at all. That is why it automatically do what? Change to 0. So if I'm to, because here now there's a, I'm differentiating a, so I will keep these 2b constant that are beside a. So you can see it constant now. So if you now differentiate just a single a, if you just differentiate just ordinary a, what will it give you? You know, whenever you are differentiating, you will use the power. You know, what is invisible? What is the power of this one now? The power is automatically raised to power 1. So you will use the 1. The 1 here to multiply what is there. If you use 1 to multiply 2b, to still give you what? 2b. Then whenever you do that, you must always subtract 1 from the power. Whenever you are differentiating, always subtract what? 1. So when I use 1 to multiply it, I will then, which is power, I will then subtract 1. So this will be a raised to power of what? 1 minus 1. And 1 minus 1 will be what? 0. So this will be a raised to power of what? 0. So 0 here, a raised to power 0, and a raised to power 0, anything, take note of this thing. Any number or any variable. When I say variable, when we say variable, we mean all those alphabets that usually see in mathematics, like A, B, C, all those ones. We call them variable. So we don't call them alphabet, they are called variable. So any number, even if it is 1 million raised to power 0, if it is 2 billion raised to power 0, if it is A raised to power 0, if it is W raised to power 0, if it is Z raised to power 0, anything, any number or variable raised to power 0 will give you 1. Take note of that. It will give you what? 1. So this becomes 1. 1 times 2b, it will still give me 2b. Always put your direction, the direction there, which is I. So this one, you differentiate it, use the power to multiply it, it become what? Yeah, now, if you use the power to multiply, it becomes 2 times a raised to power what? it's no longer a raised to power of 2, but 2 minus what? 1. So 2 times a raised to power of 2 minus 1 will be what? 1. 1. So 2 times a raised to power 1 will still give you a. So it will be give me what? It will give me what? 2a. That is how we arrive at what? 2a here. And here now, if you differentiate just a, as I've said, if you differentiate it, it will give you what? 1. So 1 times k here, because there's no a here we change to 0. So 1 times k here, if you just put the k at the back. So that would be 1k. And 1k is the same thing as what? K. That is how we arrive at this. So the same approach applicable to this. The same approach applicable to this. So just apply this same approach to this. Why this one simply means the second derivative of this. You can see that there's 2 here, there's 2 here. That is what differentiate this and this. Put in 2 here, put it 2 here. Means you then differentiate this one for the second time. But it is still with respect to what? A. So anywhere there's no a at all, if you want to differentiate it for the second time now, anywhere there's no a at all, it will automatically change to 0. So do you have a here? No, it will change to 0. Do you have a here? It will change to 0. This is the only place we have a. So if you differentiate 2a, it will give you what? 2. Don't forget to put your duration at the back, which is what? J. That is how we arrive at this. Take note of that. So why this one is the third derivative. Now this is the second derivative. Now it is now if you don't differentiate it for the second, differentiate it one more time, it will give you the third derivative. But now you are differentiating with respect to what? A. But look at this thing now. You want to differentiate it. Does it have a? It doesn't have a. So it will automatically what? Change to 0. So the third derivative here now is what? 0. So the same approach apply to B too. Just try to apply it. You will get it right. Okay. So let me erase this part so we can continue with the solution. All right. So the next one is the 46. Let's try to simplify this. Let's break down this. Okay. So please help me to be checking if there's any question again online. Let me know. Okay. So all right. So let's solve this number 6 now. Now this thing means, let me break this one down. It's just like this. It's just like this is how it looks like. I'm coming. Let me just, I'm coming. You see this one at the top, it simply means the partial derivative of this f in 3 places. So all this one that are 2 is just like in 2 places. I just want to use this one to break it down how you can easily understand this. So this one now is in 2 places. Why this one is in what? In 1 place. Okay. So this one will be in 2 places, mind you. Why this one is in what? In just in 1 place. You see that the one at the down, all total is 3. At the up 2 is what? 3. So if I have to differentiate, you begin from here. The partial derivative of f with respect to b, whatever you have, you will then differentiate it with f with respect to a. Now this is it. The partial derivative of f with respect to b, you know we have done it, which is this. Okay, which is what? Which is this. We have done it before. Now this one has already gone. So the next thing is whatever we have here, which is this. This is what we have. We will then differentiate it with respect to what? A for the second time. Now the second derivative now is no longer in terms of b now, is in terms of what? A. So from what we have here, we differentiate it for the second time in terms of what? In terms of a. In terms of what? A. So now if I'm to differentiate this now in terms of a, it will just be the combination of these 2 alone, this and this alone. So I would this is now the third one, and which is it is the third one we're actually looking for. Okay. It is that third one we are actually looking for. But before we get the third one, we need to get the second, this second one first. So now, let's have so instead of me to write the f, I can just pick 2. Because I'm joining these 2 now together. This is the first one, which is this. Now, I want to differentiate this one now. You know, this one is this. And I want to differentiate in terms of A now, not in terms of B. Whatever we have here, we want to differentiate in terms of A, not in terms of B. So, mind you that it has now becoming 2 derivative now. So let me put the f. It is still f. They are the same. So, but at the down part now, it will be combination of this and this, which will be partial derivative of a, partial derivative of b equals to. Now, why is it that I joined this one at the top, but I didn't join this one together? Because this and this are not the same. but this and this, they are the same. Okay, so what we have from here now, if you differentiate it with respect to a now, this second time, not in terms of b now, we are differentiating in terms of a. What are we going to have? Anywhere there's no a, it will change to 0. There's no a here, it will change to 0. This will change to 0. This will change to 0. So we are only left with this. So we have 2a here, 2a, and the duration is putting at the back, which is I. So if you differentiate this 2a now, what are we going to have? It will give me what? 2i. That's what we are going to arrive at here. Because a raised to power 1 times this 2, it will give me what? 2. And subtract 1 from the power, it will be a raised to power 0. A raised to power 0 will be 1. 1 times 2 will still give me what? 2. So now, the second derivative is this. Now, we are not looking for this. The question does not ask us to look for this. It's asking us to look for what? To look for this, which is the third one. Now, whatever we have now, for the first one we differentiate, we have this, which is this. For the second time now, when we differentiate this one now, for the second time with respect to a, we have this. So whatever we have now, which is this, we are going to differentiate for the third time with respect to what? A again. Okay? So if I'm to differentiate this with respect to a, therefore, number 6 will now be what? Number 6 will be it has become 3 now. Partial derivative of a with respect to a square with a square b equals to, now I'm then differentiating what I have for the second time, which is this, with respect to a for the third time. So if I differentiate this with respect to a, do we have a here? No, automatically change to what? 0. That is our answer. Is what? It is 0. It is 0. Now, this is another one. This, you see, what they did there is very simple. They are just trying to test your IQ. They want to test whether you really know what this thing means. Many students can get confused here. Help me to check. Is there any question online? Okay, no question. Okay, now let me break this one down just as I've done here. Okay, so let me break it down here. What this thing means. Now, this thing means, for example, let's do the one at the top first. It simply means the F, whatever. That's what this thing means. Now, the one at the down here, we have 2a here, right? 2a here. So we have this. So what this third one means, they are just trying to confuse you. You see the same thing as a. Do you see any b here? There is no b. So it is still the same thing as a. They are telling you that when you differentiate this for the first time, whatever you have, you differentiate it with respect to a for the second time, and whatever you have, you then differentiate it with still using the same derivative here. That is what it means. Using the same derivative of what is here, it is still respect to a. So it's just like this. That is what it means. That is what this thing means. Very simple. Very simple. So now we are going to look at the first derivative. The first derivative, it's something like, it's more or less like this. The first derivative, which is this, we have done it. You can check it. It will definitely give us 0. Where is it? Where's the square? Maybe have we erased it? Is it? It will definitely give you 0. Take note of that. Okay, so we're going to look at maybe one more question or probably maximum of 2. Let's just try to look at one more question here. Okay, you can try to write it down. Well, let me erase this question. All right. I'm coming. Now I want to ask you a question. Drop it in the comments. Have you heard about divergence and curl? Yeah, divergence. This divergence. If you have any issue with this topic, someone has a question? Is someone asking a question? Okay. Oh, he said he dropped it in the comment that he asked me a question on WhatsApp. Okay, I will check it. No problem. I will check your exam is in 22 days from now. Okay. Okay. All right. So we have divergence. If you have any issue with this topic, divergence and call this, let me know in the comments. Let me know this topic. Let me know in the comments if you have any issue with that. Okay. If you want me to prepare video on this, or if you want a live class on this, just drop it in the comments. In the comments. All right. Let's solve one more example. Hey, now let me ask you something simple here. Now let me give you this, and then I don't even know what that topic is. Okay, is it okay? Someone said he doesn't know what that topic is. Divergence and curl is in this material. It's in this material. You can check it. Is in page. The reason why I'm asking is that we have a lot to cover. We still have parabola, hyperbola, ellipse, and we still have all those circles, and we still have physics, chemistry, and mathematics. So maybe in case you exam irrespective of your school particular, because I'm just thinking of how we can balance it. So if student doesn't really have issue with that, then I may move to another topic or another course. But if student have issue with that, so we may try to go live again, a live class, and to handle that aspect very well. Although I have video on it. Yeah, you can check my channel too. Yeah, I don't need to go live for that one. I already have video on that. I did a video last year, so you can check my channel for that. So I'm dealing with those parts that we have not yet covered majorly. Okay? Go and search for it on my channel. If you don't know how to, if you are unable to find the video, then try to message me on WhatsApp. I'll send you the video link. Okay? Thank you. Now, there's another question here. This question says, but now this one is not a partial derivative. So it's just it's not a partial derivative now. Okay, physics, okay. Okay, you have tests. Which school is that? Okay, that should be, is that, okay. Okay, so you want us to go live. Okay, now do me a favor. Let me see what I can do this evening. Drop it in the comments. Which area, which part do you want us to maybe to prepare video on or to have a live class on? Just tell me the topic. Drop it in the comments, and yeah, just drop it in the comment. The topic you are talking about, or you can drop it in the comments. The topic in physics that you are talking about, that you want us to handle live class. Okay. Let me just, for the sake of your test, so let's just do one more example. Let's do one more example. Or let me just give you as what's it called? As exercise to solve. Drop it. Physics 101 test. Okay, physics 101 test full pre. Okay, I will check. I will need to check your materials, but please, can you drop the topic? The topic, is it everything? You know, it will be somehow difficult since you're having the test tomorrow to cover everything tonight. So just drop the topic in the comments that you're really facing difficult there. So we asked to find the value of this one. Now is not a partial derivative. It's automatically a total derivative. The r over the t. But now something happened here. I will just tell you what to do here. That is the first one. The second one is, now this is quite different from that first one. The r over the t square, and the next one is okay at t equals 0. Solve this, drop it in the comment. But let me show you something how you are going to solve it. You will differentiate. This is a total derivative. Why? Tell me the reason. One, because r is a function of t alone. So whenever you differentiate, it's automatically a total derivative. Two, look at the way the d is also being written. It's a total derivative. So what it means is that you will differentiate r with respect to t. Whatever you have, you will substitute whatever you have, substitute t to be equal to 0. Then find the magnitude. Let me solve this. Okay, I will solve this first one, then do the second one and drop it in the comment. Let me solve this first one. Let me solve this first one for you, so you understand how to do the second part. So we have r is given to be this. So let me differentiate with respect to t. I have what? The r over the t equals to, now if I differentiate t raised to power 2, you know, the power here will multiply it, it becomes 2 times, it becomes 2 times t. This will become 2 times t raised to power what? 2. I will then subtract 1 from it, which will be 2 times t raised to power what? 2 minus 1 will be 1. T raised to power 1 will give you t. So I will be left with what? 2t here. So here I will have 2t. Okay. Don't forget to put your I minus t. If you differentiate ordinary t, if you differentiate t, it will give you what? 1. Okay. So it will be 1j, and 1j is the same thing as j. Okay. Plus, if I differentiate 2t, what will it, now this list does not have t, is 0. So it's a constant. This is a constant. This is a constant number. So it will be 0. So here now, if I differentiate this 2t, what will it give me? 2t. You know, the power here is like 1. So if I use the 1 to multiply these two, it becomes 2 times 1. That will be 2 times. Now, t raised to power what? I will subtract 1 from it, which will be 1 minus 1. And 3 raised to power 1 minus 1. This will be 0. T raised to power 0 will be 1. 1 times 2 will give me 2. So that will be what? 2k. I'll put 2k. I'll put k at the back, which is the duration. Now, I've gotten t now. So we're now told that at t equals to 0. So what it means is that wherever I see t, I will substitute it with what? With 0. I will place it with 0. So therefore the r over the t equals to, if I put 0 here, this will be 2 times 0. And everything here, anything multiplied by 0 will definitely give you 0. So here is 0. We'll be left with minus j plus 2k. Now, I've gotten this, I've differentiated this, and I've substituted t inside it. So I can then find the magnitude. What is magnitude? So the magnitude of this, the magnitude now of the r over the t equals to, just since it is 2, what is the coefficient of j here? It's minus 1. If you put minus 1 square plus, what is the coefficient of k here? That is 2 square. So this will give us minus 1 square is just like minus 1 times minus 1. Minus times minus will give you plus. 1 times 1 will give you 1. So plus 1 is the same thing as 1. So we have 1 plus 2 raised to the power of 2. That will be what? 5. That will be 4. Sorry, that will be 4. Okay. So here now we have root what? Root 5. That is the answer. We can't break this one further. We can't break it further. So our answer there is root 5. All right. If you find this video, this class helpful, please consider to share, consider to like, consider to comment. Drop your own opinion, drop your suggestions. If you anything bothering your mind, drop it in the comments. Share, subscribe. Not just subscribe, turn on the notification button so anytime we go live, you can always get notified. All right. Thank you very much. See you in the next class.